Hello friends, welcome to Unacademy and welcome to the today's session. In this session, we are going to discuss about how the layers are organized with the backbone devices. If the backbone devices are attached, then how the layers are being behaved and how many times the each layer may occur during data transmission we are going to discuss. So before entering into the details of the today's agenda, we will say our anthem that let's crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost best educators. In order to get the topmost content from topmost educators, you all need to take an admission into Unacademy so that you're going to access all the complete material and stuff which are there in an academy so that you can access daily live classes and you can also see that quizzes and mock test and many other. You can also get the faculty interaction by filling a form. About myself, Srinivasrao IS, having more than 15 years of experience in the computer science stream. I had also an industry experience as a system analyst and admin. Through journey of my GATE, I taught in many premium academies, including the GATE Forum, GATE Academy, Vani, and many others. With a high success rate, many of my students, since all the last 17 years, many of my students have achieved and cracked the GATE examination and settled as a topmost software engineers and good MNCs. Most of my students are working in Amazon and many other MNCs. Friends, you also can get such kind of opportunities just by achieving an examination called GATE. So to achieve this examination GATE, you need to require a proper training. The training enables that you're going to get some kind of shortcut tips and some kind of how you can able to solve the problem. Such kind of guidance you also get through the corresponding faculty members. To get the admission into an academy, use my referral code. You're going to get the maximized discount. So my referral code is Sankara so that you're going to get a good discount. An academy also launched Iconic Batch so that you're going to get many more benefits in the icon with the iconic badge. You're be part of plus courses as well as you'll also get a complete guidance from the academy faculty members. Therefore, friends, as far as my experience concerned, you take subscription in iconic badge so that you're going to get one-to-one interaction with the concerned faculty members and the guidance people from an academy. So utilize this opportunity to get into Iconic Badge so that plus courses are part of Iconic. So you're going to get benefited from both of them such that huge number of live quizzes and huge number of test series and huge number of live classes, unlimited live classes and unlimited hours. This is the format of your Unacademy. So this there are two kinds of subscriptions, 12 months and 24-month subscription. So for current fourth year students can obtain 12-month subscription and the second and third year students can obtain 24-month subscription. Once after taking your subscription, you're completely a member of an academy so that you can able to access all the contents. That means all your restrictions are removed as you're facing as one of your free class member. Let us start today's lecture. If you are having any kind of guidance required, then fill this form so that the corresponding faculty member will interact with you immediately. So let's crack GATE CSE in a positive vibration. Subscribe Unacademy YouTube channel. Nothing that. Let's crack GATE CSE. Use my referral code to get the maximized discount. hit the bell icon for latest notifications and updates. So let us start our lecture, that is organization of layers. When you are talking organization of layers, our main motto is that when there are some kind of hardware devices are there, then how the layers are going to be reacted, we would like to see. So the last previous session, we learned that what are the backbone devices are there. In the last session, we learned that how the layers are being interacted using a concept of peer-to-peer process. So now we are going to see that what are the types of backbone devices, how they are going to be reacted when you are using a concept of layered structure. Layered structure is a mandatory in a computer network data transmission, even in Wi-Fi 2. So without having any kind of a layered structure, you cannot able to have the data transmission concept. So therefore, my dear friends, now I'm going to give you one small diagram and see that how the layers are being interacted with that. If you are talking the layer slide, application comma presentation comma session, we are calling them as user support layers. And the other name of them is nothing but what? Software based. And the other name of that is nothing but end-to-end layers, because they never deal with a media, basic medium. So when you are talking transport layer, we learned that it is an interface between your user support layers and hardware support layers. So this is interface between the upper group and the lower group, that is layer 5, 6, 7 and layer 1, 2, 3. We also noticed that it is also end-to-end layer. Now friends, the last very important crucial part is that the last three more layers, that is called network and data link and physical layer. We call them as what? Interlinked layers. They are called as interlinked layers. Also they are called as hardware support layers. So now most of the cases we are facing a problem with the last three bottom layers only, because layers are going to be behave in different way whenever you attached these backbone devices. Now I am going to give you one good example so that you will understand why there is a necessity of the organization of the layers. Now friends, observe now. I am saying there is a node 1. And here we have a node 2. They have got connected directly using the medium. Please understand. Now he is going to ask a question that how many times each layer is involved in data transmission. Each layer is involved in data transmission. That means simply they are look like nodes only, but before you want to start data from sender to the receiver, you all need to see that. So what is the kind of a layered structure you are using, whether OSI or TCP/IP? If I am considering as such that, for example, your realistic model is your TCP/IP. If you are considering TCP/IP, then what is going to happen? So sender side, that means a node 1. I am thinking node 1 is the sender and node 2 is the receiver. Then what is going to happen? The node 1 is involved with your application layer, as well as involved with transport layer, as well as involved with internet layer, as well as involved with that is link to link layer. So friends, we can understand such that, so application layer here also sending data to transport layer. So we are using application layer one time, and transport layer is involved in order to send your data in the form of segment. Therefore transport layer is also used one time. And internet layer is also we are using to find out the shortest route. And this is also going to be used because it has to send the data to the next layer. That's the meaning of use. And now finally, your link layer is also used to push your data into media. Therefore, friends, each layer is occurring one time at the sender side and the receiver side also. When data has come here, then your link layer takes the data and send those bits or frames to upper layer. Therefore, link layer one more time is used here. And your internet layer is taking the route and it is going to send the data to your transport layer. Now, transport layer will send the data to your application layer. Finally, what do we understand, friends? Each layer is interacting one time here and one time other side. So one time here, transport layer and the internet layer, one time here. Here also, data is going towards unstripping your headers. It is going towards upper side. Therefore, every layer is involved. So it is also used one time and one time and one time. So finally, he asked that how many times each layer is involved in the real-time data transmission. Each layer is involved two times. One is at the sender side, one is at the receiver side. So now, if I am giving another example here, so what this example is saying, I am saying there is a node 1 who is acting as a sender and there is a node 2 who is acting as a receiver. Between them, there is a hub is used in order to transmit your data. So finally, what is happening? You want to transmit data to your node 2. I am taking a one LAN connected device, nothing but hub. Now here what happened? First node 1 has to contact to your hub. Then your hub is going to push your data to other party. Now this time you understand carefully. The hub is a hardware device which is acting as an interface between both the nodes. Now this time the layers are behaving in different style. How? Let me tell you. This time I'm taking OSI. So here I said that application presentation session and this side also application presentation session did not know that there is a medium existed between sender and receiver. Therefore, they directly communicated from one side of the sender to other side of the receiver. So naturally we come to know that they are been executing two times only. One time at the sender, one time at the receiver. Please understand carefully. And when you come to the transport layer is also end-to-end layer. What is the meaning of end-to-end layer? The sender and the receiver side transport layer do not know that there is a medium existed. So that's the meaning of what end-to-end layer. One time at the left-hand side party, other time is with the right-hand side party. So remaining hardware devices doesn't bother. Therefore, here also the transport layer is used twice. One is at sender side and one is at the receiver side. So we confirm that it is also two times. But when you are talking about internet layer, now it is also going to react only two times only. We all may get a doubt that I said internet and data link layer and physical layer are hardware related. So in order to attempt this kind of a questions, you need to understand that where this kind of hardware can be positioned. Now I am giving you a hint here. What is that hint? Please observe carefully. I am saying hub is a layer 1 device and we see that bridge is a layer 2 device and we also see the third one switch is a layer 2 device. Now you talk about the router which is going to be layer 3 device. Please understand carefully. According to the layer standard, the corresponding layers are involved in real-time data transmission. Therefore, in the previous example, I have used only hub, not any other. As I said that hub is a layer 1 device. Therefore, all other layers are not at all involved in that. They knows that that medium is not belongs to us. Therefore, data link layer also do not know that there is a hub existed, and it is also going to use two times only. But you understand carefully, physical layer is not like that. Physical layer knows that there is a hub existed between me, because hub is belongs to layer 1 device, hence it is going to react how many times, friends? 3 times. By 3 times in the sense, please observe like this. As hub is a layer 1 device, now here what is going to happen? You send the data to here. That means you are the source and you are the destination. And when hub received the data, now it is going to act as what? I am the source and I am going to transmit your data to other party. Now you are the destination. Therefore, physical layer is involved in order to transmit your data like this. Because whenever you call that physical layer, it is a concept called line to line. So line to line it is going to consider. Now you see that the physical layer is involved here, as well as the physical layer is involved here, as well as the physical layer is involved here. Now if I am giving another example here, I am talking these examples only in perspective of LAN. We will see example on WAN also. Now understand. Now I am saying there is a sender by name node 1 and there is a receiver by name node 2. Now between them there is a device called a switch. Please understand carefully. Now when I am using a switch, now how the layers are going to be reacted. So when I am transmitting data, the data will come to the switch and the switch is going to forward your data to other party. Now here our question is that how many times the each layer is involved in real-time data transmission. So understand friends carefully. Now here we know that switch is a layer 2 device directly. So when switch is a layer 2 device, it is not going to interact with the upper layers. Therefore, you can confirm your answers that application, presentation, session, transport and network layers here and there they are using one time. Therefore, altogether they have used 2 times while transmitting of your data. But you see that the switch can be understandable by your layer 2, that is nothing but a data link layer. Then here what is going to happen? It takes that switch. Here is the switch. Now DLL will send your data to your switch and from there data is going to be forwarded to other particular node. However, DLL used in the same way because layer 2 device, when I am saying that it also works with layer 1. Therefore, what happened? It also works with a physical layer and physical layer knows that there is an intermediate node between sender and receiver and takes the data and transfer to your corresponding physical layer. Now here we have see that how many times we have got this to here. We say that physical layer to physical layer the switch is being gathered. From there it is going to give you data to data link. So finally friends, we understand that the switch how it is acting at the data link layer. However DLL is it is playing and the same physical layer is also going to be interacted. That means when you are working with the upper layer with one device, automatically lower layers are also going to be utilized. Therefore, DLL is used especially in switch and physical layer is also used in switch concept because when I am saying that DLL, the particular device can be working and the same style, it can also work it physical layer also. That means the DLL, I'm talking about the mainly DLL only. So DLL push the data to PL and DLL first interact with here. Here there is a DLL. It interacts with DLL. Then physical layer is interact with its own physical layer. Then this physical layer will transmit data to other side physical layer. Then DLL also will understand that as like this. So when we are talking about the data link layer, it is trying to deal with the what? MAC addresses. Now let us see one more scenario example. So I'm saying there is a sender here and there is a receiver. Please understand, friends. And there is a switch here and there is a hub here. Okay, now how they are going to react? We know that application starting down to internet layer, they do not bother about these mediums. The data is coming down by taking a concept of encapsulation. The data is going up by doing a decapsulation process. But you see, we know that switch is a layer 2 device. Therefore, what happened? DLL is interacting with your switch because the DLL is a link to link based or hop to hop based. It know about one junction. It do not know about other junctions. But DLL do not know about what? Your hub. So remove your hub here because hub is a layer 1 device. Therefore, this here exactly DLL is going to be used with your switches. From there, other DLL is going to be used. Now, however, DLL is used with a switch and PL also is going to be used with your switch. Therefore, it also interacted with your switch physical layer. That means what? Switch has got a two-layer device. That means it can work with the data link layer to understand the MAC address. It also work with the physical layer to understand what is the protocol you're running in that particular physical layer link. So now the physical layer of sender will interact with the physical layer of your switch. Please understand. Now after that, there is a one more device I said. What is that? Hub is also placed among sender and receiver. Therefore, hub do not know about your upper layer device. Hub only knows that physical layer can understand. Therefore, my dear friends, this physical layer will interact with this physical layer and from there data will come to this physical layer and it handed over to data link. So how many times physical layer come? Please hear. It is here because data is coming to physical layer. This link has to send the data to this physical layer. So we are using, and from this link to this link, the data is coming, we are using, and from this link to this link, we are using a physical layer. So you have got as many devices are there, those many links you require. But DLL, you understand, as the switch is a layer 2 device, it do not know that upper layers do not know that there is a medium is existed. But as a switch is used in DLL and PL also is supposed to have what? Same concept. Now let us take a two switches concept. When there are two switches are available, what will happen? I say there is a sender and there is a receiver. Between them, there are two switches are involved. So whenever two switches are involved, you immediately get a strike. What is that? DLL is used here and DLL is used here and physical layer is used here as well as physical layer is used here as there is a switch 1 as there is a switch 2 while transmitting your data. Therefore friends, remaining layers application dot dot to internet layer, here also application dot dot to internet layer, they are end to end only. They do not know that there is a medium exist between the node 1 and node 2, nothing but sender and receiver. But did this particular switch can be understandable or can be understood by your data link layer so that it will interact, so that this will interact, so that it will interact to other side data link layer. Now here, in the same way, this information will carry forward to this and this information will carry forward to this because ultimate layer who involved in a real-time data transmission is physical layer only. Therefore, physical layer is also, the data will come from sender to your physical layer, from there to next link of your switch and from there to next link of other switch, from there to next link of your original receiver. Okay friends, so this is the hierarchy that the sender and the receiver are having a what? Two switches between them while doing a what? Data transmission. You all may get a doubt that why there are two switches, because I want to do what different LANs I want to do. So when you want to do different LANs and there is a requirement of what, either multiple hubs required or multiple switches required, or you see that switch is a maximum of 24 port only. You want to have a 40 system, so you cannot run with a what, single switch. So this was your one of your previous gate question. What is the previous gate question? So I will give you roughly the question like this. I say the question is like this. I want to say that 40 systems I need to connect. 40 systems need to connect over a LAN. Let us say 48 we will take. Now you see that he is using a switched Ethernet he is using. So when I am saying I am using a switched Ethernet in the sense he has to tell you that how many ports are there in that. So naturally we are having 32 or 24 port switches. If I am taking 24 port switches, that means a single switch I can able to connect 24 systems at a time. So there are, as like this, there are ports are there so that you can able to connect them. But he said that 48 systems are there. So 24 port, one switch I am taking, and 24 port, other switch I am taking, and here also I can able to connect 24 systems. But when you connect like this, they become what? Different LANs. They are not a combined LAN. You want to say that they are a combined LAN. What is required? You need to go for what? Uplink. This is very, very important. Uplink you need to do. So when you have uplink to other particular port, now this switch and this switch can able to communicate easily. Now they all becomes a what? Single LAN now. So while doing uplink, you have to dedicate a one particular port and you have to dedicate a one particular port here. So remove these ports as they are using a what? Uplink or junctions between these two switches. Hence, you cannot keep 24 systems here. You can keep only 23 numbers only. Here also you cannot keep 24 systems here. You can keep only 23 systems, but I need to have 48 system. Therefore, what is required? One more switch is required, and which is required what? One uplink port. Please understand. Again, I am doing a reverse strategy. So again, there is a uplink from there. So here I cannot keep 24 or I cannot keep 23. I can keep only how many friends? 22 systems here and 23 systems here, and the rest 3 systems, because I have got other ports also. Rest 3 systems I'm going to keep it in other switch. So switch 1, and this is a switch 2, and this is a switch 3. So how many switches required? 3 switches required. See the beauty of this question and logic of this question. So if you are having any doubt, you can chat with me by typing. If you are having any doubt. So this is what is the meaning of a switch. So in that case, why we are adding a switches in the sense we want to what? Integrate a more number of computers into a single centralized LAN. Now come to our regular approach. Our regular approach, I'm saying that between sender and between receiver, this time the very important hardware device is being placing. That's what? Router. Please understand. There is a router. So already we discussed about the hub, already we discussed about the switch, and now the third layer, that is a backbone device, came, that is called a router. As I already told you, router is a layer 3 device. When router is a layer 3 device and upper layers do not know that there is a intermediate node existed, so directly they can able to communicate application and others, and up to transport. They feel that they are end-to-end communication only. They do not know that there is a what? A router is existed. But who knows that there is a router existed? We all know. So internet layer knows that there is a router is existed because router is a layer 3 device. Layer 3 can be understandable by your particular router. So when I'm saying a router in the sense, this is a layer 3 device which has internet layer capability, which also has data link layer capability, which also has physical layer capability. So it is working with three layer structure now. When I am saying a switch, it can work with the data link layer and physical layer. When I am saying a hub, it can only work with the physical layer. But when I am saying a router, it can able to work in all the three layers. That means it is a three-layer structure. The router is manufactured in such a way that it can understanding routing techniques, it can understanding MAC address techniques, it can understand that through which line I need to transmit your data. So my dear friends, it's a very simple to answer. What is that? IL is used one time at the sender side, IL is used one time at the receiver side, and IL is used router at one side, but DLL is used and PLL used double time. This is the what? A logic. So PL and DLL is being used double here. Why? We will see and learn. This was your 2012 GATE question. Is that he will give you a router. You need to identify that how many number of times the internet layer is being presented and how many number of times DLL is being presented or how many number of times the physical layer is being involved in order to do the data transmission. As far as this example concerned, DLL is used here at the sender side, physical layer is used here at the sender side, DLL is used here receiver, physical layer is used here at the receiver side. So you see that this is what is the meaning of what? Interlinking. So this is interlinking. What is interlinking? Now internet layer and your data link layer and your physical layer are interlinked now while doing data transmission, as those three layers are called as what? Hardware based layers, also called as intermediate layers. But you see that internet layer is not purely hardware and data link layer is not purely hardware. They are software and hardware, but physical layer is only last bottommost layer is called only purely hardware layer. Remaining all topmost supports only software, and the remaining three can support hardware as well as software. But the last layer is purely what? Hardware based only. It is a dumb layer. Now why? Now we want to see that why the internet layer is involved only one time with router and why DLL and PL is used double times while transmission of your data. So altogether 1, 2, 3, 4. 4 times DLL used, 4 times physically is used, but 3 times network layer is used. Now let me tell you another example before going into the details. So when I'm saying there is a node 1 which is connected through a router to other side. Now I am telling you the very important, I'm telling you the very important secret, because now we are doing a what? LAN to LAN integration with the help of routers. I am making into a WAN. Please understand carefully. He belongs to one LAN, he belongs to another LAN, and now these two LANs I want to integrate because both are different private networks. I want to integrate them. There is a need of a what? Router or gateway. I'm taking a router here. Router has got two ports. Naturally, by default, you can have any number of ports, but two ports you can say minimum. Minimum you require two ports. One is incoming and the other one is outgoing. Incoming is your LAN port, outgoing is your WAN port. Please understand carefully. This is your WAN port. Now this LAN port is configured with private IP. You will learn what is IP and all later on session. And WAN port is configured with public IP. Now friends, understand carefully. So while you are transmitting data with the help of a router, the router is going to perform a NATing. So last session we discussed that what is the meaning of a NATing. And NATing is nothing but what? Conversion of your private IP to public IP and public IP to private IP. You will see this everywhere. You want to give me real-time example? I will give you. For example, myself X. I want to access google.com. So here google.com is a public network, or you can say that public site. But I am a private member. How are you going to access this? It's impossible because it is under www. So you can access only with www.google.com only. So I am a private member. So I want to access google.com. So what I am doing? I want to migrate to public member. So how are you going to migrate to public member? Just by connecting to what? Internet. Please understand. When you connect to internet, then internet is going to give you a public IP. Please understand why we are connecting to internet. We are connecting to internet to acquire a public IP. By taking this public IP, so as you are a public member, you are now free to eligible to access any kind of a site which is there in www. Now I can access. But before you are trying to access, it is not possible because you are become a what? Private member. That's why you are connected to internet in order to access the public site. Now this is what? What is this? It is trying to give you a concept called NATing private IP to public IP. Now I will show you the previous example like this. I'm telling you. So this LAN 1, this node 1 is configured with a private IP. And this node 1 is also configured with the private IP. Now what is going to happen friends? Observe carefully. This private IP, I want to make them communicate. But it is not directly possible. That's why there is a requirement of what? A WAN device. Now router is a WAN device. It's not a LAN device. Please understand. Hub and switches are the LAN devices. Router is a WAN device. Wide area network device as well as internet device. Therefore, you understand this particular incoming port is configured with private IP. And now what I am going to do, this private IP can able to communicate with this private IP. Because private IP of that LAN and private IP of that particular LAN port of your router, here to here, I can able to communicate. As this is treated as a one link, please understand. Now from the data I need to put it out as you are coming with a what private member and I am taking you as a private member. Now what I am going to do? I'm trying to NAT you. What is the meaning? Conversion of your private member to public member. Then your private IP becomes a public IP. Now you can simply access other guys, those who are in other particular networks. If at all they have a router too there, that side, you need to do the same concept there also. Now I am making a big complexity. Please understand from here to here, it is a link 2. And both links are connected or integrated with the help of a router. Now let me tell you one more example. This time I am going to see that this is your LAN 1. To that node 1 is connected and this is other side I am taking here. This is a LAN 2. We are some other state. I am some other state and node 2 is connected. I want to send some information from there to here. So what you need to do is, it is not directly possible, we know, because private networks they are corporate networks also called as a private networks. Both are same. Corporate networks are nothing but what? Not a public network. They are private network. They can able to work with the intranet fashion, not internet fashion. Internet means it is a public network. Intranet means it is a corporate network or private network. Now, how I am going to send the data to them? It's very simple. There is a requirement of what? A router. And this side also is taking a router. Please understand. And when you have a router, the router has got two ports as I told you minimum. One is showing a face your side. So it is being configured with private IP. And this side also, which is showing your side, it is a what? This port is configured with private IP. As myself is also configured with private IP. And here also, this side, this member is also configured with private IP. Now you see friends, the link, the node to the particular link can able to communicate. How they can able to communicate, please understand. As this node 1 is also having a same range of address private IP, then I can able to communicate up to this part. But I don't know how to go out. So here also, this man node 2 can able to communicate up to this particular point, as it is also one of your private network and one of your link. Therefore, what is going to happen? Here to here, I can say that it's one of the link, and here to here, I can say that it is one of your link. Now we want to send our data to out. Out means public network, which is nothing but internet. When you are saying that public network, it is nothing but internet only. So far we performed conversation up to private. Now private has to convert to public. Now we will give a task to the router. Router is going to perform NAT. We will give a task to the router. Router is going to perform NAT. It is one of the software algorithm which is written in your router. Now to this port, public IP is configured because that port is called as what? WAN IP. It is called as WAN port. So WAN port is going to be called as what? Or configured with WAN IP. WAN IP is nothing but public IP only. Simple. Please understand all these terminologies. You want to become an expert in computer networks. So now WAN port is being configured with a public IP. Who are going to give you the public IPs? Question mark. Who are going to give the public IPs? Can anybody respond through the comment? Who are going to give you the public IPs? Are they freely usable? Anybody can give you comment. Who are going to give you the public IP? So this side also same style. What is that? It is also configured with the what? Public IP. As that port is a what? WAN port. And you say that WAN port is being configured with a WAN IP. And WAN IP is nothing but what? Internet IP, also called as what? Public IP. I gave you a clue now. So now you tell me friends, who is going to give you the public IP? Internet. So you need to purchase internet or you need to connect to internet, then automatically you have got acquired what? Public IPs. So public IPs are not freely usable. They are worthy. You need to purchase them either by taking a leased line, direct line, or by taking a broadband internet. That's why we people are connected to internet before accessing any kind of a website in the triple W. Now you see, now I became what happened? You are coming with a private IP up to this link. Yes, it is also private IP. Now here to here you can communicate, and a router takes you and converts into what? Public format. Now you are become a public format now. Please understand. And here also this side we will look at now. He can able to communicate up to private IP. Router try to put you into public member by doing a network address translation. Now you become a public member. Us. Both of them are become a public member, and this particular network and this particular network are being communicated with the help of that is one more component is required. What is that? All our conversations are being fallen into exchange. This is very important. What is this? This is what is the meaning of telephone network. So all your cover conversations are come to telephone exchanges. So therefore, friends, without PSTN, this is what is the meaning of public switched telephone network. Without PSTN, you cannot able to send any kind of data. Now see the beauty of this architecture. See how the router is going to put you two different private networks together into what? A single larger network. That is what is the uh, duty of your router by doing a shortest path, as well as it also performs what? NATing, network address translation. Now, why I'm teaching this point? Because we come to a device called router, and I said that the router is going to be implemented in internet layer. Therefore, the router can understand internet layer format as well as DLL format as well as PL format. We are having a doubt here that why DLL is come twice and PL has come twice in the router. Now let me put it here. So when I'm saying a router, or when I'm saying sometimes the other name of router is nothing but WAN device. When I'm saying a router or a WAN device, I'm taking one WAN device which has got two functionalities. One functionality NAT and the other functionality shortest path. Please attend evening classes so that you will come to know what is a routing and what is the other routing algorithms we are using, that I am going to start on Unacademy student learning app as a free classes only. Just to download the app, then you're going to get it. The timings are from 6 p.m. from tomorrow onwards. Now here, this is your router. So at what are the layer it is been implemented? So router can understand, it cannot understand application, I don't know, it cannot understand presentation, cannot understand session, cannot understand transport, cannot understand. Router can understand only three layer because it's a three layer device. That is the internet layer it knows. That means it knows that packet format, it knows that data link layer, which is nothing but it can understand a frame format. It can also knows that the what is one is one another one, that is a what, it can understand a what, bits format. So when I am taking a router, it is being configured with a layer 3, which is nothing but it can understand internet layer, data link layer as well as physical layer formats too. But I said that how come DLL is used twice and how come PL is used twice? That's what our doubt since start of the router concept. Now I'm telling you exactly, come to the point. So I'm saying there is a node 1 which is integrated with a router 1 and which is integrated with router 2. Please understand, this is a crucial point. I can make you by heart that DL is used twice and PL is used twice, but I want to give you the reason and the technique behind that. Please understand the technique. So here what happened? We come to know that these are the two routers which are used between your two devices. Now therefore, application layer and here application layer, they do not know about these two. Transport layer do not know about these two. Direct to direct, but internet layer knows that there is a router, we can understand that format, there is a router and there is a router. This can understand DLL format, no doubt. This can understand DLL format, no doubt, because it's a layer 3 device which can also physical layer as usually there and here can understand physical layer, it can understand physical layer. One important secret I want to tell you here. When you are talking a router, directly it handovers the data, it finds the shortest path and gives to other particular router. And this router is going to find the shortest path. Immediately it informs to the other particular internet layer that this is how I am coming. But you observe when you are talking a router which has got this here to here one link, please understand, here to here another link and here to here another link. Therefore, my dear friends, you understand carefully. Data link layer is a link to link based. Data link layer is a link to link based. It is not end to end based or it is not host to host based. But internet layer, please understand, transport layer is a end to end based. and the internet layer is a host to host based. What is a host? IP to IP. It can able to communicate from IP to IP. So that's why it is called host to host. But DLL, when you are talking, it is hop to hop. I do not know about other particular hops. I know about my immediate next point only. What is your immediate next point? Please understand. My immediate next point is this only. So I am acting as a source and you are acting as a destination. Please understand. So here also once again this time it is removed old source and old destination because the data has come to the next port here. Please understand. Second port. So therefore it is going to treat that this is my source this time and my next link is this is this is going to be your destination. Please understand. Now from here to here another link because data link layer is a link to link or hop to hop or MAC to MAC based. Here MAC is going to be changed. Please understand how it is going to change. I will tell you. Once again we will take. This is going to act as a new source and this is going to act as a what? A new destination bus. So you got to understand that DLL is used here one time. DLL is used here other time as I have received you. And DLL is used as I am keeping a new source. And DLL is used as I am giving a new destination. Source and destination is modified because only junction to junction only the DLL knows. Once soon after you goes to the next destination, old source and old destination will be changed and new so that destination becomes a new source and a new destination will be added. Again come to the point and now this is your exactly old source. This is your first destination. Now this destination becomes a source. And now this is the next destination to you. Now this destination becomes a source. Now this is the next immediate destination to you. Now this becomes immediate source to you. Now this becomes a what? Destination to you. Therefore, it is going to consider what? Source and destination. So therefore, the DLL is used exactly to identify the destination point and DLL is used exactly to identify a what? New source. And again DLL is used to identify a destination and again DLL is used to identify as a what? A source. Therefore, my dear friends, you understand carefully to identify your new source and a new destination and elimination of your old source and old destination. DLL has come twice here, one here, and one here and one here, and as usual DLL is at the other side. This is the reason behind that. And the same story is also happening. What is that? See this. I am marking red and black. Red is a source to you and this is your first link. Please understand here to here is a one link. After that that is going to be act as next port is there now, that is going to act as a what? Now it is going to act as a new source. Now it is going to act as a new destination. Now from there the data is going to be passed. So from here to here the data is being passed and here to here data is being passed. Now after that again you got new source and a new destination. This time the data is passed from there to here. Now you understand as usually PL is playing there and PL is playing there, but you got 4 times here to identify destination and source, destination and source. So PLL is used here and PLL is used here, PLL is used here and PLL is used. This is how DLL and PL is used twice, especially with a what? A router, because during data transmission, the link address will be changed in your frame, but the IP address is not going to be changed during data transmission. I'm telling you one important point, observe. So during data transmission, IP address is not going to be changed. During data transmission, IP address of a packet, IP address of a packet, which consists of what? Source IP address and a destination IP address. They are not changed during data transmission. But which is going to be changed? We know. Link address is going to be changed. That's what the meaning of link. Link is nothing but what? Which can be jointable, which can be disjointable. Please understand carefully. Now what is going to happen? As it is a concept called network layer or internet layer. Now when I am talking about the data link layer, what is happening? Link address is changed. So during data transmission, this is nothing but a linked list. During data transmission, MAC address is changed. Very, very important question. MAC address of a frame, please understand. MAC address of a frame which consists of source MAC, which consists of destination MAC, medium access control address, changed at every link. Please understand, at every link it visited. Okay, so now let us see our previous example. What is our previous example? Now I'm going to give you final example before closing this particular router concept. I say there is a node 1 and there is a router 1 and there is a router 2 and there is a node 2. This is our structure. Now I say this is having one IP and this is having one IP and this is also having IP address. This is also having IP address. Because without IP address you cannot able to have the communication over internet layer concern. Therefore IP is not going to be changed. I am talking about internet layer concern. Packet 1 has source address and destination address. This is your source, this is your destination. Between the routers are trying to give you shortest path. Which line I should go so that it is going to be the shortest to me. That is going to be informed by your routers. So when N1 sends data to R1, please understand, N1 sends data to R1, your source IP, I am saying 0.1, destination IP, I am saying 0.2. So this is going to be recorded in your packet, source IP and destination IP. So when the node 1 sends the packet to router 1, what is your source address? Please say, what is your source address? Router 1. You can type through comment. What is your destination address? 0.2. Okay, up to node 1 to router 1, this is called a link 1 and this is called a link 2 and this is called your link 3. Now you understand. Second step. Now router 1 is trying to transmit data to router 2. So what is your source and what is your destination address of your packet 1? Source address and destination address doesn't change. Please understand. That will be 0.1 and 0.2 only. That is not going to be changed. And the third step you understand carefully. Next link. What is that? Router 2 is going to give the data to node 2. Again it is looking as internet layer responsibility. I need to understand source address and destination address. Again same 0.1 and 0.2. I am the final destination because see that I am the final destination. I got the data not from R2, not from R1. I got the data from N1 only. That's why from address and to address is not going to be changed. Please understand carefully. But which address is going to be changed? That is the link address is going to be changed. Now I will show you in the next example how link address is going to be changed. Now I am talking about the MAC address. MAC address is called as a link address, also called as a hop address. Now I am talking node 1 which is connected with a router and which is connected with the next router and which is connected with the node 2. Please understand carefully. Now I am giving you two addresses. IP I am giving 0.1 and here also IP I am giving 0.2. So I said that while your data transmission this address won't change. Even internet layer I'm talking, when internet layer receives the data, other side, when internet layer of a router receives, when internet layer router receives, the address will be same. That's what everybody will understand, that 0.1 is the source and 0.2 is the destination. 0.1 is the source, 0.2 is the destination. Here also, that means all internet layer feels that that is the source and that is the destination. But I'm giving you MAC address now. Observe carefully. Observe friends. Now I'm giving you MAC address now. So MAC address always in the form of hexadecimal form. I'm giving you simply, for example, AB is your source MAC, N1 MAC, and N2 MAC. This is also, every port has got MAC address, no doubt. This has got E and F. Now you see, this router 1 also has got MAC. I say two ports are there, router 1. One is input and the other one output. So input and output. Now you see, it has got two MACs now. What are the two MACs? Let me write. One MAC 0F and the second port MAC is 1E. And this particular R2 has got 1M, DE, and next it is going to have BC. And the destination I already given you as a what? EF. Now you see, during data transmission, what is going to happen? I said that link address is going to be changed at every visiting link. Please understand carefully. So when I send data to this, then what is your source? Please understand. Your source is AB and your destination is not EF. I don't know about EF because EF is so far away as far as data link layer concerned. But internet layer knows that somebody is my destination, but data link layer do not know. Therefore, what happened? Your immediate destination it knows. That's what 0F. Right. Then after it is going to R1, what R1 is going to think? It eliminates its AB as your source. It eliminates 0F as your destination. It adds new MAC, new source and new destination. Therefore, what happened friends? Observe carefully. R1 removing your frame and remove your data adds new MAC as a source and new MAC as a destination. Therefore, it tells that I am your source now. What is your source? 1E is your source. And next immediate destination to me as what? DE. So your destination is a what? DE here. See, this is how the MAC is got changed. That's why I said DLL is used how many times? 2 times. One is elimination, one is at adding. So DLL is used twice, 2 times. In the same way, physical layer also feels that link to link, I need to hand over the data, not end to end. That's why PL also is going to be done 2 times. Now come to the next router. When this router receives that, okay, my source is this guy. So I understand that I got this particular frame because that DLL is going to sense the data in the form of frame only. SA is 1E and destination is a what? DE. So it eliminates that old source and old destination. It is going to add its own source and its own destination. Then your new source is a BC here and a new destination is a EF here. So therefore here also elimination of your MAC and adding of your new MAC is being done. Now it goes to other layer. So now finally exact destination has come as per a DLL I am talking. Now in this DLL it opens that frame and sees that my source and my destination. I am the destination EF. I need to take the packet. And who is my source? It's not AB. Please understand. AB is gone. And now my source is what? My next previous link only. What is my previous link? It's nothing but from here to here. So this is how the MAC address is being eliminated. The MAC address is being eliminated and adding a new MAC addresses is done, especially by the data link layer. In the same way, physical layer is also going to be happen. But IP address is not going to be changed during data transmission, friends. Understand carefully. During data transmission, as many routers or switches you have, we don't mind. from address and to address are the same, but MAC address is going to be changed at every visiting a router or at every visiting link. Clear? Now come to our example. Final example I will give you so that now you are comfortable to say that how many times each layer is involved. I say there is a sender and there is a receiver. Between them, two routers are there. Router and switch and router. Take a situation like this. Assume now you all can say that how many times each layer is going to be interacted. Very simple. How many times? A router is not an application layer or transport layer device. Therefore, AL is a direct to direct. It doesn't mind that there is a media exists between them. And transport layer doesn't mind that there is a media exists between them. Two times. There here, one time here. One time for the decapsulation, one time for the encapsulation. But internet layer knows that there is a router to me. So it involved here, but it is not involved. It is involved here and it's involved here. And but data link layer, you understand here, it involved here double time and it involved here data link layer. And here it is going to involve here. Then finally it is going to involve here. In the same way, physical layer is also involved there and here also there, and finally. Okay friends, this is how you can able to say the answers. Last question, using a gateway. I discussed hub repeater also same. Repeater is a layer 1 device. Only layer 1 can able to decide, identify, remaining nobody. Now gateway is all layer device. When I'm saying gateway is all layer device, therefore, there between sender and receiver, if there is a device called gateway, then what will happen? So gateway, I said that 7-layer device. What is the meaning of 7-layer device? In that the programming, it has defined that it can understand all the formats from application to your physical layer. Therefore, application and application and application, same story. Transport and transport and transport, and internet layer and internet layer, and as usually same story, data link layers and physical layers, because they will understand that there is a gateway between them. Okay, so if gateway is acting also router, then it is because gateway is also sometimes similar to router only. Okay friends, so how this is organized, I will show with one diagram. We see this is one of your network. This is one of your network. A to R1 is a one link, and R1 to R2 is another link. R1 to R3 is another link. R3 to R4 is another link. R4 to final destination is another link. R2 to R4 is another link. There are many links are there. But the main concept of a router is nothing but what? Identifying a shortest path. So that's why it has taken an aerial route that this is your shortest path. What is your shortest path? Already it is given. The data is traveling like this. This is your shortest path, and B is the ultimate destination to us. A is the source address. In between, there are some routers which are integrated links. Now you understand carefully. Physical layer, how it treats. I already said physical layer is a link to link. It takes the data, hand over to one link, and from there that link to it is going to hand over to other link. See now. A is the source. My destination, exactly this particular point only. What is that? A router. Router has got two interfaces, I said, right? Router has got two interfaces. One is for LAN interface, one is a outgoing WAN interface. So up to first interface, it left the data. So this is what it takes the data exactly first LAN interface. It put the data here. So PL is used one time here and one time here. Now next link is going to be your source. Therefore, PL is one of your next link, and your input link of your router is going to act as a PL. Next, this is going to be next physical layer, and this is going to be next physical layer. Finally, we are going to hand over the data to other party. Why? I said that physical layer is a what? Line to line, which is basically depends upon your data link layer. However, data link layer is reacted double time with your router. Physical layer is also acting in the same way. Now you understand, friends. So this is how the communication is at the physical layer. So one time source, one time destination. One link is a source, one link is a destination. So let us see a few of the important points of your physical layer. It is a line to line based. It is a line to line based, and it treats every link as a separate line. This is very important. Every link is a what? Separate line only. If I'm saying this is your link, then it is a separate line. That's why in your example, what has happened? From this particular A to this particular point, it is a one line. That's why every link is a what? One line. And next one, when you are contacting, so physical layer supports all types of protocols. There is no specified protocols for physical layer. All protocols can able to follow this. So here also at this time, the communication is between two hops or two nodes or two computers or two routers, which is nothing but it knows that you are my next link. Up to there only I am going to give the data, and next link is supposed to send the data to next link only. So what is the unit of PDU, protocol data unit of your physical layer? Protocol data unit of your physical layer is nothing but what? A single bit or bits. If there are n links are there, then there is a requirement of what? N physical layer protocol. And next one, you talk, data link layer. I already explained about data link layer. It is also MAC to MAC or hop to hop based. Every link is a what? Separate. During data transmission, MAC address is going to be what? Changed. The PDU is a what? A frame. Now you see how the diagram and how the data link layer is going to react. I said that whenever a node A is transmitting data, whenever node A is transmitting data, and the immediate link is going to be my destination. My immediate node is going to be my destination. Therefore, E is the source, it is the destination. Again, the other port is a source, and the next port is a destination. Again, other port is a source. That means what? The removal of your MAC address. Sometime the format of your packet is also going to be changed. That is also reason, one of your reason. What is that? One router may follow one kind of format, other router may follow other kind of format. For example, I am following IPv4, somebody is following IPv6. Therefore, there is a requirement of changing this kind of MAC addresses and inside frame data. And here also, this is going to be act as what? Destination. Now the next link starting point is a source and next link ending point is a what? Destination. So this is how, see that source, destination, again source and destination, and source and destination, next port source, next port destination. Okay, and next one, what's the reason? The reason is like this. Whenever your frame is transmitting between node A to R1 may be different from the next routers. Please understand that is router 1 and router 3. What he is talking here? Between A, I am transmitting data to first link of R1 and R1 has to send the data to R3. This format may be different from this format. That's why I am changing your word. Deleting of your old data and adding of your new data according to my requirements of R1. R1 is not a source, R1 is a destination. Soon after receive the data, I need to convert according to the format required by other party. That's why I'm changing old data and adding new data. So whenever the frame is received by the router R1, this router passes the frame to the data link layer. What the data link layer is going to do? The frame is opened and data are removed. It is going to add once again a new headers and the same data in a different format. And the data are then passed to data link layer of next particular router. So why? Because we know that the inside formats of these links may be using a different protocols. It may not be the same protocol what I am following. I am also saying sometime if I am following IPv4, some other person may follow IPv6. For example, I am following wide LAN. If I am following a wide LAN, other particular guy may follow what? Wi-Fi. These are different standards. That's why their standards may not be what? The same. And we already seen communication at data link layer. Communication at internet layer is somewhat different than yours that. So it is mainly looking for what? Identifying a shortest path only. So it is seeing that data is going to be transmitted in the form of a datagram, and the datagrams are being traversed via different routes to the destination. So that means what? The packet can go like this or the packet can go like this if there are multiple paths are there. It's not compulsory that all the packets to be transmitted in a single path. I'm showing you like this. Sometime the packet may go like this, or sometime the packet may go via router 2. This is going via router 1, this is going via router 2. Due to what? Some kind of delays. We will see later on in the upcoming classes. Next one, the datagrams can travel along with the different routes and can arrive out of sequence or maybe duplicated, or some are maybe also what? So IP is not going to keep a track of all the routes, and there is no facility of reordering of what? Your datagrams once they arrive. And the communication between your network layer is in the form of what? End to end. So I already said how the layer is going to be organized here. Please see. So this network layer straight away is trying to identify a shortest path which tells to the data link layer and physical layer. Next, once soon after receive data, it also try to identify the shortest path and it will tell the down layers, and which also going to give the shortest path which tells to the down layers, because routers are mainly give you what? Shortest path. That information they are going to tell to the down layers like data link layer, physical layer, such that you need to transmit data only the selected route which is given by your routers only. That's very, very important. That's why internet layer is used only one time in the router, because it's not going to change your IP addresses there. As there are three routers are there, 3 times internet layer work and 1 time at source, One time at a what? Destination. But data link layer is not like that. Please understand. It is a one time, it is another time. It is a one time, it is another time. It is a one time, it is another time. Sender side once, receiver side once. Now we will see transport layer communication. It's a segment to segment concept, end to end concept. It doesn't feel that there is some kind of a medium is existed between the sender and receiver, except gateway and firewalls. So what is its duty? It is trying to send the data in the form of what? Segments. It is trying to send the data in the form of what? Segments, and those segments can become packets or datagrams. So each datagram has to be delivered to the network layer, because transport layer has to send the data to internet layer. Internet layers has to send the data to data link layer. From there it has to send data to physical layer. This is in the form of segment. This is in the form of packet or a datagram. This is in the form of a frame. This is in the form of what? Bits. So whenever other side you see that same story, decapsulation is going to happen. So data should come there, frame, data should come there, packet or datagram, data should come there as a segment. Once transport layer not immediately going to merge them, it is going to wait till all the fragments of the particular segment will come. Then only it is going to merge. That's very, very important. After merging, it will hand over to whom? Application layer. As application layer is only send the data which was in the form of what? Messages. Please understand. The transport layer at the destination needs to wait until all the datagrams have come which are belongs to same segment and assemble them, then send it to the application layer. This is how the communication at transport layer direct communication, because router and switches and hubs are no way linked to your transport layer. That's why straight away whatever it is being transmitted, it straight away went to what? B, as low router, switch and hub is not belongs to transport layer. The same feeling you also going to see at application layer. What is that? Application layer is going to provide some kind of a user interface access to access data through private networks or access data through internets. Private internet is nothing but, my friends, intranet, and global internet is nothing but your public network, which is nothing but what? Internet. And it is going to offer many kinds of protocols. I listed three here. Email, which is nothing but SMTP protocol, or and IMAP protocol. Together you are going to send and receive mails. File transfer protocol, FTP as well as TFTP, and the other one WWW as well as DNS. Together you are going to send a what? So that's it, friends. This is how the organization of layers. Tomorrow's session we are going to see the transmission modes. Transmission modes, that is a parallel transmission and a serial transmission, which is asynchronous and synchronous. So this is our schedule for tomorrow, which starts sharp 2 p.m. Let's crack GATE ESE is our YouTube channel. To subscribe to that, fill that form, then they are going to redirect a faculty member so that they are going to give you. This is about a YouTube session. And tomorrow evening, I'm going to start a special class. Don't miss these special classes. Very complex topics I'm going to discuss in the special classes, as it is called as a special. So tomorrow is your 6 p.m. special class is there. This is about tomorrow. That is Friday. So I'm discussing tomorrow session is what? Routing. In that I am discussing the very one of the important protocol, distance vector. Your syllabus has got two protocols, distance vector and link state routing and flooding. So tomorrow I am going to discuss about what? Distance vector. Day after tomorrow, count to infinity. After that, flooding. Don't miss the special classes. I am going to announce the next day's schedule in the current lecture, so that don't miss those timings. Subscribe your YouTube channel. You will get the latest notifications about my classes. Don't miss any of your computer classes. Very much important in real time, especially in the companies when you are working. This knowledge is sufficient. This knowledge is sufficient what I am teaching. So that's why please watch my DBMS and operating system lectures, which are also there in the same YouTube channel. Follow me for DBMS lectures as well as operating system lectures. Complete lectures are there in that YouTube channel. And tomorrow evening special class, I'm going to discuss computer network routing concept, and I'm going to start a plus course. Maybe day after tomorrow, I'm planning. This plus course is only for what? This plus course is only for those who are Unacademy students, not free of cost. YouTube lectures all can listen, special class free lectures all can listen, but plus course is only for the students of Unacademy only. You want to become a part of that, you want to learn a DBMS in depth and efficiently, because I'm going to give one more recap as far as GATE and your BTech curriculum concern, or MCA or MTech, whatever it may be. So I'm going to start a DBMS lecture from scratch. It takes around almost all 40 to 50 lectures. Don't miss this chance. Don't miss this chance. If you are not become an Unacademy student, immediately subscribe. Immediately subscribe to subscribe and to get the discount. You're also going to get the good discount which are offering by Unacademy. So use my referral code. So you're going to get a maximized discount. Clear, friends? So tomorrow session we will meet sharp by 2 p.m. and evening 6 p.m. we are going to see a routing concept, that too distance vector I am going to explain. So we'll meet in the tomorrow session. Thank you very much all of you who are on live. So please watch this lecture. This is my third lecture as far as computer networks concerned. Yesterday one lecture and before day one lecture has happened. Please watch them. First lecture is backbone. Second lecture is peer-to-peer process. Third lecture is today one, that is organization of layers. So I also gave you DBMS lectures in that. You please follow them, and operating system lectures are also there in a very simple manner. You please watch them and give your valuable comments and give your likes, because a lot of effort our faculty members are keeping in order to prepare the digital content. So please give us a valuable comment and please give a like to us. That will give you utmost satisfaction to us. So thank you very much. We'll meet in the tomorrow session 2 p.m. Please download Unacademy student learning app from Play Store and find for computer network classes and search for Srinivasrao. So my name is Srinivasrao. Search for Srinivasrao. You are going to find all my free classes of DBMS and OS and currently running computer network classes. Share this knowledge to everybody. Share this Let's Crack CSE YouTube channel to everyone and advertise our Unacademy student learning app to all your friends. Thank you very much.